Hi! Today we'll discuss about determination of integrating factors. Let us consider this differential equation m dx plus n dy equals 0. Previously, we've discussed that if the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x, the differential equation is exact. And if the partial derivative of m with respect to y is not equal to the partial derivative of n with respect to x, it is not exact. But we can make it an exact equation if we multiply the whole equation by a function mu. It can be a function of x and y, or it is also known as the integrating factor. Take note, pag sinabi nating integrating factor, this is a factor multiplied to the whole equation that makes it an exact equation. If we multiply the function mu sa ating whole equation, we'll get mu m dx plus mu n dy equals 0. And this differential equation will be exact kasi nga minultiply na natin siya by the integrating factor. Now, we need to determine this integrating factor mu. And to solve for this integrating factor mu, we apply the exactness condition. Let us consider the previous equation that we have. Let's take the partial derivative of mu m with respect to y and the partial derivative of mu n with respect to x. Since this is now an exact equation, then these two will be equal. So we'll apply the product rule. First, we'll take the partial derivative of mu with respect to y multiplied to m plus the partial derivative of m with respect to y times mu equals the partial derivative of mu with respect to x times n plus the partial derivative of n with respect to x times mu. Rearranging this so that lahat ng may factor na mu ay nasa isang side lang. So lipat natin si partial of n with respect to x times mu sa left side and lipat natin si partial of u with respect to y times m sa right side. And factoring out mu, we'll get if we take a look on this equation, it will be quite complicated to solve for the integrating factor mu. But there are special cases that we can consider. The first case is that if mu is a function of x only. So if mu is a function of x only, then if we take the derivative of mu with respect to x, dahil nga function na lang siya ng x, so derivative of mu with respect to x na yon. And if we take the partial derivative of mu with respect to y, take note, dahil function of x na siya, pag dinifferentiate natin siya with respect kay y, that will be considered a constant, kaya siya ay equals to 0. Considering now the previous equation that we got, we can now cancel the term m times partial derivative of mu with respect to y. Switching sides, we'll get n times derivative of mu with respect to x equals mu times partial of m with respect to y minus partial of n with respect to x. Dividing the whole equation by n and mu, we'll get. Take note that if mu is a function of x only, then the right-hand side must also be a function of x. This differential equation is quite simple to solve because this is a variable-separable differential equation. Separating all the terms with mu and x, we'll have. So we now just have to integrate. Then applying the formula for natural logarithm for the derivative of mu with respect to mu, we'll get ln of mu equals the integral of the right-hand side. Now, since we want to solve for mu, what we'll do is to take the e of both sides and we'll finally solve for mu as a function of x that is equal to e based to the integral of 1 over n times the partial derivative of m with respect to y minus the partial derivative of n with respect to x dx. This is now the integrating factor mu if mu is only a function of x. Take note that this can only be applied if the right-hand side is also a function of x. Pwede niyong itanong, nag-perform tayo ng indefinite integration pero hindi tayo nag-add ng integration constant. Take note na hindi tayo mag-add ng integration constant kasi isang integrating factor lang naman yung hinahanap natin. So, yun yung reason bakit hindi tayo nag-add ng constant na c. Another special case that we can consider if mu is a function of y only. If mu is a function of y only, then the partial derivative of u with respect to y is equal to the derivative of mu with respect to y. And since it is only a function of y, pag tinake natin yung partial derivative niya with respect kay x, dahil considered siyang constant, that will be equal to 0. We can now cancel this term n times partial derivative of mu with respect to x. Rearranging this, then dividing the whole equation by negative m times mu, we'll get Again, dahil si mu ay function ng y lang, therefore, the right-hand side, 1 over m times partial derivative of n with respect to x minus partial derivative of m with respect to y must also be a function of y only. And gaya ng ginawa natin kanina, to solve this differential equation, we'll just separate the variables. Pagkasama-samahin natin lahat ng mu and d mu and lahat ng dy. And applying the same formula for the left-hand side to integrate, we'll get ln of mu equals the integral of the right-hand side. And to get mu, we'll just take the e of both sides to cancel ln. Therefore, mu as a function of y is equal to e raised to the integral of 1 over m partial derivative of n with respect to x minus partial derivative of m with respect to y dy. Halos hawig lang din to nung kanina, except that pinagpalit natin yung n and m. Tapos pinagpalit din natin ng location yung partial of n with respect to x and partial of m with respect to y. Now, from this, we can summarize na kapag meron tayong differential equation of the form na m dx plus n dy equals 0 and hindi siya exact, if we get 1 over n multiplied by the partial derivative of m with respect to y minus partial derivative of n with respect to x, and yung nakuha natin doon ay function lang ng x, we can determine an integrating factor mu na function lang din ng x, and that is equal to e multiplied by yung nakuha nating result. Kapag naman ginawa natin yung 1 over m multiplied by partial of n with respect to x minus partial of m with respect to y, and nakakuha tayo ng term na function lang ng y, madedetermine natin yung integrating factor for that differential equation that will make it exact, and that is equal to e raised to the integral of 1 over m times partial of n with respect to x minus partial of m with respect to y dy. Let us try to solve some examples para makita natin kung paano ba gumagana or ginagamit ito. Problem number 1, quantity x squared plus y squared plus 1 dx plus x times quantity x minus 2y dy equals 0. Distribute lang muna natin si x dito sa terms na to. As you can see in this equation, this is of the form na m dx plus n dy equals 0. Check natin kung siya ba ay exact. To check kung siya ay exact, we'll take the partial derivative of m with respect to y. Then later, we'll take the partial derivative of n with respect to x. X squared, that is taken as constant, that's y0, plus y squared, derivative is 2y, plus derivative of 1 is again 0. Simplifying this, we'll have 2y. Next, let's solve for the partial derivative of n with respect to x. Derivative of x squared is 2x minus derivative of 2xy. So, 2y, then derivative ng x is 1. Simplify natin ulit to. We'll get 2x minus 2y. Comparing this two, we can say that they're not equal. Therefore, this differential equation is not exact. Let us try to divide the difference of these two terms by n. So, dahil i-divide natin yung difference ni partial of m with respect to y with partial of n with respect to x, ang ina-expect natin dito ay function of x. So, tandaan nyo, kapag ang pinang-divide ay n, ang ina-expect nyong result dyan ay function of x. Pag ang pinang-divide ay m, ang i-expect natin result ay function of y. Gamitin ko na to as n. Multiplied by the difference of partial of m with respect to y, 2y, minus this, 2x minus 2y. This equal to 2y minus negative 2y is 4y minus 2x. Mai-divide ba natin to? As you can see, we can factor out negative 2 para makapagpalabas tayo ng x minus 2y. So, factor out ko na dito yung negative 2 and we'll get negative 2y plus x divided by x over x minus 2y. Common term, c, x minus 2y, so we can cancel this out. And from this, we get the result negative 2 over x, which is a function of x. Dahil yung nakuha natin kanina ay function of x, therefore, yung ating integrating factor na mu is also a function of x. So that is equal to e raised to the result that we got from the previous solution, negative 2 over x dx. Integrating this will get e raised to negative 2 ln of x. By applying the logarithm rule, na pwede natin gawing exponent ito, we'll have e ln of x raised to negative 2. And e raised to ln of x raised to negative 2 is just this term. Kaya naman yung ating integrating factor is just equal to x raised to negative 2. Anong gagawin natin ngayon sa integrating factor na to? I-multiply natin siya sa original equation para maging exact yung ating original equation. Multiply lang natin siya from the previous equation, x raised to negative 2 times x squared plus y squared plus 1 dx plus x raised to negative 2 multiplied by x squared minus 2xy dy equals 0. Simplify lang natin to. X raised to negative 2 times x squared is 1 plus x raised to negative 2 y squared plus x raised to negative 2 dx plus, this is again 1 minus 2 x raised to negative 2 plus 1, that is negative 1 times y dy equals 0. In-expect natin na after natin i-multiply yung integrating factor sa original equation, this should now be exact. So, i-test natin ulit kung siya ay exact. This is now the new m. Partial derivative of 1 is 0 plus, taken as constant, derivative of y squared is 2y plus, taken as constant. Then simplifying, we have 2 x raised to negative 2 y. Next, partial derivative of n with respect to x. Constant minus, taken as constant, derivative of x raised to negative 1 is negative 1 multiplied by x raised to negative 2. Simplifying this, 2 x raised to negative 2 times y. Comparing these two now, we can see that they are equal. Therefore, the differential equation is now exact. Question, paano kung minultiply mo na yung equation by the integrating factor, tapos nung chinek mo kung siya ay exact, ay hindi siya nag-exact? Ang ibig sabihin lang nun, possible na mali yung nakuha mong integrating factor or mali yung pagkakamultiply mo. So, i-check mo na lang ulit. Dahil exact siya, gamitin natin yung mga previous solution na ginamit natin for exact equation. For this, I'll just try to use the third solution that we did, wherein we integrate all the directly integrable plus the integral of non-directly integrable equals constant. Classify natin kung sino yung mga directly integrable and non-directly integrable. Pag directly integrable, function siya ng x and dx and function siya ng y dy. Kapag may combination, so non-directly integrable yun. Ito ay function lang ng x and dx. Same with this. Bakit ito naging function ng x? Basta hindi siya y, function siya ng x. Next, ito ay function din ng y dy. So, integrate natin lahat ng directly integrable. 1 plus x raised to negative 2 dx and 1 dy. Lahat ng natira ay non-directly integrable na and pipili lang tayo kung sino doon yung i-integrate natin. It's either x raised to negative 2y squared dx or negative 2 x raised to negative 1y dy. Ang pipiliin ko kay non-directly integrable ay ito. So, integrate natin lahat ng directly integrable. Integral of 1 plus x raised to negative 2 dx plus this, integral of dy, minus integral nito, non-directly integrable, and that is equal to a constant. Integral ng dx is x plus integral ng x raised to negative 2 dx is x raised to negative 1 over negative 1 plus integral of dy is y minus, so dahil ang integration ay with respect to y, so lahat ng dy ay taken as constant. Integral of y is y squared over 2 equals c. Simplify natin ngayon yung equation natin by multiplying the whole equation by x kasi meron tayong negative exponent and we usually write the answer with positive exponents. X times x is x squared. This will be minus x raised to negative 1 times x is 1 plus xy minus 2 y squared over 2 equals cx. Then, rewrite lang natin na from highest power to lowest power. So, unahin na natin to. And notice na pwede natin i-cancel si 2. X squared minus y squared plus xy minus 1. That is equal to cx. As you can see, this is now the general solution of the differential equation that we have.